So um, the last thing we did was multiplying polynomials. Today what we're going to do is look at factoring polynomials. It's kind of the opposite process. Like when we do prime factors, we divide a number up into all the things that if we multiplied them together, we would get the original number. It's the same idea here. We're going to take a polynomial and divide it up into things that would multiply together to give you the original. Why is it important? The reason that this is important is for solving equations. If these are equal to 0, then after you factor them, you can set each one of the factors equal to 0, right? That's called the zero factor property for algebra. So the first thing you always want to do, and students sometimes overlook this, is look for a common monomial factor, which is to say, is there something that will divide evenly into everything? So what is it that divides evenly into both terms, the 3x squared and the negative 12? 3. And that leaves you with 3 times x squared minus 4. Now, we will go back and talk about factoring this further. This is not factored completely because x squared minus 4 can be factored further. We'll talk about that in just a second and remind you of how to factor the difference of two squares. For this next one, what is it that we can factor out of all of these terms?
4x.
Yeah, 4x. That'll leave me with a 2x squared minus 4x plus 5. And we'll talk again later about, well, is it possible that this could be factored? Or is it possible that it doesn't? God bless you. That it doesn't factor. That's always a possibility. So with binomials, after you've factored out, remember binomial means you've got just two terms. After you've factored out any common factor, the only way a binomial is going to factor anymore is if it's the difference of two squares, meaning it's something squared minus something else squared. And the reason for this is that when you multiply a plus b times a minus b, when you distribute a times a is a squared, a times negative b is negative ab, then you distribute the b times a is positive ab, and b times negative b is negative b squared. Notice that these two terms have the same value but opposite signs. So that drops out because those add up to 0, and you end up with a squared minus b squared. So if you can think of something as being a squared minus b squared, the factors will be a plus b times a minus b. And by the way, the order is not important. If you write a minus b times a plus b, it's the same thing. So like this, for x squared minus 25, you want to think of it as x raised to the second power times 5 raised to the second power. I don't require that people write that out. You know, a lot of you are already very quick at these and don't need to begin to do that. So then it's just x plus 5 times x minus 5. You can always check, no matter what kind of problem you're doing, you can always check to see if your factoring is correct by turning around and multiplying them back together. If it's not equal to the original, then your factors are wrong. So it's always possible to check. All right, so then for one like this, or we've got 9x squared minus 64, 9x squared would be what squared? Yeah, it's 3x, quantity squared, minus 64 is 8 squared. So this factors to 3x plus 8 times 3x minus 8. The next one, refer back to rule 1. The first thing you always do, no matter what, is look for any common factors. What's the greatest common factor for these two terms?
3x squared.
Yeah, 3x squared. do that first. That'll leave you with a 4x squared minus 9. Right, and that's, I'm not going to take the time to write it out this time. That's 2x squared minus 3 squared, so it'll be 3x squared times 2x plus 3 times 2x minus 3. And again, the importance of that is if this was an equation, we could now solve that. Also, if you were graphing y equals to that, you could find where this crosses the x-axis. You could find the zeros of the function. All right, so let's talk about factoring trinomials. The simplest kind are the ones where the leading coefficient is 1. That means that the number in front of the highest powered term is a 1, which means it's usually not even bothered to be written. So let's notice why this particular idea works. If we take x plus a times x plus b, we distribute that out, we get x squared plus bx plus ax plus a times b. Notice both of those have an x in them, right? So if I group those together, I could factor an x out. I'm going to put it in the back because it looks more like what our problems are going to look like. When you do that, you've got x squared plus a times b, a plus b times x plus a times b. So our goal in factoring is going to be to figure out what those numbers are. So we're going to want a number so that, or two numbers, so that they multiply together to give you the constant term and add together to give you the linear term. And this is why. That's not just someone made up this rule and you're supposed to follow it. I hate it when we as mathematicians do that. We explain things and like, here's the rule. And you're like, well, why is that a rule? This is why. All right, so for this, then, we just need two things that multiply together to be 21 that also add together to be 10. Yeah, x plus 3, x plus 7. And if you distributed this out and grouped the like terms, you would end up with this. You would end up with a 21 from the 3 times 7, and you would have a 3x when you multiplied the 3 times the x, and a 7x when you multiplied the x times the 7. And an x squared, because x times x is x squared. So when they're both positive, I think this is pretty easy if you know your multiplication and you can add. So here I want two numbers that multiply together to be 12, but add together to be 8. Yeah, 6 and 2. And again, the order's not important. Now for this next one, I'm still going to start with an x and an x because I have to have an x squared. I want two numbers that multiply together to be positive 15, but add together to be negative 8. Well, what must be true about both of these numbers? They're going to have to both be negative, because if one was negative and one was positive, when we multiplied them together, we would get a negative answer. So here, I know they both have to be negative. And the two numbers then would be, 3 and 5 or 5 and 3. Again, the order is not important. So that when I add them together, I get a negative 5 plus negative 3 is negative 8. And multiply them together, I get 15. So same thing here. They've got to multiply together to be positive 35, but add together to be negative 12. So if it's going to work at all, it's both going to have to be negative. Yeah, 7 and 5. I think those really aren't too much more difficult than the ones where it's both positive. The one where it's a little harder is the one where the last term is negative, because then you have to figure out, all right, which one needs to be positive and which one needs to be negative. Because if we want things that multiply together to be negative 24, one of them has to be positive and one of them has to be negative. So again, I know that it's going to start with an x and an x, so that when I multiply those first terms together, we get x squared. There are lots of different ways I could get negative 24. I could have positive 24 and negative 1, negative 24 and positive 1, all kinds of stuff. And you just kind of in your head kind of go through those things. It's called the guess and check method. In your head, you're just thinking of numbers that might or might not work. There are other methods. There's a whole method called splitting the middle term, which is useful when you get really hard ones, I think, but not for ones that are a little more straightforward. So, I know I've got to have a positive and a negative, and I know the negative one's got to be bigger, because I have to end up with negative 5 when I add them together. So, this is plus 3 minus 8. So again, they both got to start with x and multiply together to be negative 36. And again, there's all kinds of things. It could be 18 and 2, or it could be 6 and 6, or all those different things. You have to spend a little time thinking about what's going to work. A negative 4 and a positive 9 is correct. And then this last one in this set is a reminder to factor out any common factors first. The common factor in those three is x squared, the greatest common factor. And this will be x squared minus 6x plus 40. Oh, excuse me, minus 40. I was just looking at that going, that's not going to factor. And does not factor is always a possibility. Sometimes it just doesn't. And you're like, yeah, not factorable. So we want two numbers that multiply together to be negative 40 and add together to be negative 6. Negative 10 and positive 4. Precisely. All right, now let's get to what I think are the hardest ones. So if the leading coefficient is not 1, start by factoring out a common factor. Sometimes after you pull out the greatest common factor, what you have left does have a leading coefficient of 1 and you can just factor it. Sometimes it doesn't. So on this one, we can factor a 2 out of every term. And then what's inside my parentheses does have a leading coefficient of 1, so I can just factor it like I've been doing the other ones. Both going to start with x. I need two things that multiply together to be negative 35. There's not a lot of things that do that. And add together to be positive 2. 7 and -5. Yeah, positive 7, negative 5. Same idea works for this next one. The leading coefficient here is negative 1, so I'm going to factor out a negative 1. So I'm dividing every term by negative 1, so that changes everybody's sign. So now we'll factor this, the x squared minus 12x plus 32. I need two things that multiply together to be positive 32, but add together to be negative 12. That ensures they both have to be negative.
-4, -8.
Yeah, negative 4 and negative 8. Okay, when you get to ones like this next example, where you can't factor out the leading coefficient, these are harder. I mean, they just are. Okay? And you can, if you want, spend some time and do guess and check until you get the right thing. But you can also split the middle term. Did you guys do splitting the middle term in Algebra 2 this year? All right, let me remind you how the rules for splitting the middle term goes. So what we're going to do is multiply the lead coefficient and the constant. So we're going to multiply 3 and negative 5, so that's negative 15. So here we want to find two numbers that multiply to the result that we just got and add to the coefficient on the linear term. So it's sort of the same, you have to do one extra step, but there's sort of the same process in terms of finding those two numbers. We want two things that multiply together to be negative 15 and add together to be negative 14. What would those two numbers be? Yeah. Negative 15 times 1 is equal to negative 15. And negative 15 plus 1 is negative 14. So those are my two numbers. It does not matter which one you do first. It really does not. What I'm going to do is I'm going to divide up this middle term, this negative 14x, into two different parts using these two numbers. Because I wrote the negative 15 first, I'm going to use it first, but it doesn't matter. So I'm going to write 3x squared minus 15x plus 1x minus 5. You did this? Okay. And then what you do is you kind of group the first two together and the last two together and factor out the greatest common factor for those. So what is it that I can factor out of both of these? The 3x. When I do that, I get 3x times x minus 5 plus the only thing I can factor out of x minus 5 is a 1, right? There's no other common factor. So 1 times x minus 5. If you have done this correctly, these two will be the same. If they're not the same, then you haven't done it correctly. And at this point, you're like, I've got 3x times x minus 5 and 1 times x minus 5. Oh, so I've got a 3x and a 1 times x minus 5, and that's the factoring. I like splitting the middle term for ones where the leading coefficient isn't 1 most of the time. Sometimes I just look at it and go, okay, and I think about it for a little while and I can come up with the right answer. Sometimes it's really ugly, especially like on this one, since it's 3x squared. Well, I knew one of them was going to start with 3x and the other one was going to start with x. And then a very little bit of guess and check and I could have gotten here. Okay? But sometimes this first is like a 12x squared and you're like, okay, because it could be 12 and 1, it could be 6 and 2, it could be 3 and 4. And then you've got to do all the possibilities for the last term. It just gets to be too much. All right, so let's try that on these next couple of ones. Let me show you how you could do it by guess and check, and then we'll do split the middle term. It's a little bit more concrete. So for guess and check for this one, I know that it's got to be a 2x for one of them and an x for the other one, right? And then I know that they have to multiply together to be 21. So either 21 and 1 or 3 and 7. Not a lot of possibilities. But then when I multiply it out, it's not that those two numbers add together to be 17. It's when I multiply them out, will they add together to be 17x. So let's say that I put 7 here and 3 here. Don't write it down yet. We're just going to look. If I multiplied, that would be 7x and 6x. That's not going to make 17x, is it? I need it to be bigger, don't I? So let's switch them. Let's put 7 here and 3 here. This is going to be a 3x and a 14x. Add those together, that makes 17x. That's it. Now, you can also do this by splitting the middle term. Do 2 times 21 is 42. So sometimes people talk about this in terms of target product and target sum. I want two things that multiply together to be 42 and add together to be 17. 14 and, yeah, it's 14 and 3. So I'm going to go 2x squared plus 14x plus 3x plus 21. I can factor a 2x out of both of these, and that'll be x plus 7. I can factor a 3 out of both of those times x plus 7. And I know that I've done it correctly because both of these, when I factored them, left me with a binomial of x plus 7. So that's 2x plus 3 times x plus 7. Splitting the middle term takes a little longer. If you can do it by a little bit of guess and check, I think it's worth it to do that. This next example is one I was talking about where I'm like, if I have to start guessing, there's so many different combinations I could have. Because with 12, I could do 12 and 1, 6 and 2, 3 and 4, and then 18 could be 18 and 1, 9 and 2, 6 and 3. So many different combinations. Yes, ma'am?
I think for the split the middle term, you still need to get the total and then to find if it will add up to the middle term.
Yeah, but it's easier to, then you're not, like if I guessed that this was 12 and 1, and then I started guessing all the things with the 18, I got to go through a lot of different possibilities.
But 12 times 18 is still really large.
It's pretty big?
Yeah.
I suppose that's true. So if we do, let's take a look. If we do 12 times negative 18, let's see, that's negative 180 plus another 36 is negative 216. And yeah, fully admit, I don't immediately go, I know a whole bunch of ways to make 216 by multiplying two numbers together. That said, I know that they need to be fairly, they don't need to be, it's not going to be 2 times 108 because I want this to be negative 19. So even 4, I'm thinking probably 8 and something. Maybe not. Okay. So, but if you start doing it, you're like, okay, if I did 2 times 108, well, that's never going to work. And I could do 3 times 72. No matter how I do that, that's never going to make negative 19. 4 times 54. Like, okay, I'm getting maybe a little closer. 5 won't go into it. 6 must. 6 goes into that. 3, that's 18. That's 36. 36, that's not going to make 19. Pardon?
It is 8. Is it 26?
Is it 8? Yeah, well, I said earlier, I would have started with 8. How many times does 8 go into 216? 27? And if the 8 was negative, that works. Because I know the relative size of this, I know kind of where to start. So I'm not starting from, if you go through all of this, you're really spending a lot of time. So 8 and 27. All right, so 12x squared. And it needs to be a positive 8x and a negative 27x, doesn't it? So then out of these first two, I can factor a 4x. And that'll be 3x plus 2. And then for these last ones, I'm going to factor a negative 9 out of it because I want this to be 3x plus 2. I want it to be the same as the other one. So it's 4x minus 9 times 3x plus 2. That's about as awful as these get, for this class at least. Okay. Let's see something real quick. Wednesday. Yeah. All right. So the other lesson that we're doing today is on graphing linear expressions, which should be a review for you of stuff that you're really good at from algebra and pre-algebra. You will need a piece of graph paper. I don't know why I did. You'll need a piece of graph paper for your notes. I apologize. I should have just done my notes on graph paper and left room, but I didn't. Hey, and this will be your last notes for the year.
Actually, wait, it is? No,
Yeah.
fine.
I think so. I could be wrong, because that's always a possibility. But okay, so let's remind you of some things from Algebra 1 and before. So when you're graphing a line, the first way that you learned to graph a line was slope-intercept form, y equals mx plus b. or y equals b plus mx, which I think actually makes more sense because that's the order you graph them in, right? I've always thought that. I'm like, why did you do it this way? And it's because French people came up with this, and they think they're. So you know how in American English we will say the white car.
Right.
If you were speaking in, and to be fair, most other languages, you would say something where you said the car first and then it was white. You would say the car that is white. You wouldn't say the white car. So anyway, not important, just rambling on about English and its interesting features. So when you graph an equation like this, you plot the y-intercept, 0b, and count the slope. Remember, the slope is the change in y divided by the change in x to find a second point, and then you can draw the line. Now, if you're not using a ruler, what I do is I always, I do several dots till it goes to the edge of whatever my grid is. Point slope form really gets kind of the short shrift from Algebra 1 textbooks. I think it's more important because it leads to things in calculus. I teach calculus, so I'm biased that way. So point slope form, depending on which textbook you're using, can be one of two ways. Either y minus y1 is equal to m times the quantity x minus x1, or, and this is my personal preference, but it doesn't really matter, y is equal to y1 plus m times x minus x1. So x1, y1 is a point on the line. One of the nice things about this is sometimes the y-intercept is a horrible value. And yet somewhere it's going to go through a lattice point. That's where your horizontal and vertical grid meet one another. Somewhere it's going to go through a nice point. Why not start with that one rather than some horrible y-intercept? And m is still the slope. So to graph from this form, plot the point x1, y1, then count the slope to a second point, draw the line. Just as a reminder, if you have negative 3/5, that's the same thing as negative 3 over 5 is the same thing as 3 over negative 5. That's helpful when you have a limited grid and your first point may be really close to the edge, and you're like, oh, if I go down 3 into the right 5, I'm already off the grid. Instead, I could go up 3 and to the left 5, and then I'd be on the grid. Okay? And then horizontal and vertical lines, y equals a or x equals b. Y equals a is a line with a slope of 0. Notice there is no m, right? No slope. And the y-intercept is 0a. Honestly, the way I think about this, and I don't know if it's helpful, I'm like, if it's y equals, say, 3, then the only axis that it goes through is the y-axis, and it goes through the y-axis at 3. Likewise, when I get x equals b, the only axis it's going to go through is the x-axis, and it's going to go through at whatever the point b is. That's going to be a vertical line. That helps me remember those and not get them confused, because it is easy to start getting in your head about those. All right. So let's graph some of these. Wow, that's really, really, really dialed in. I hate it when I do that. All right, graph paper. That's a little better. And I apologize that all my numbers are upside down. It's not my fault, but I could rant about Apple products and not caring about the fact that things don't work anymore because it's not our product. We don't care. All right. Sorry, I need to move this over first and then graph. Okay, so for this first one, we've got y equals -3/5 x plus 4. This is, something that I would expect my 7th graders to be able to do. The y-intercept is at 4. The slope is -3/5, so we go down 3 to the right 5. We can also go up 3 and to the left 5, because a +3 over -5 is the same thing as -3 over +5. So I could go up 3 and then I can graph a line. I get to cheat because I have a built-in thing that draws them straight. It looks something like that. We can also do inequalities. So let's take a look at that. So we start off drawing this just like we normally would. The y-intercept is at +5. The slope is 7/3. Well, here, obviously, I'm not going to go up 7 into the right 3. That's going to be way the heck up here. I'm going to go down 7 into the left 3 because a negative over a negative is equal to a positive. So down 7 to the left 3. Now, I have a couple of points, but before I start drawing the line, I notice that this is strictly less than. There is no equal to underneath it. Okay, so what that means is it's not the line. It's everything up until the line. Now, for mine, what I'm going to do so that I can use my straight line tool is I'm going to draw the line, and then I'm going to go back and erase things. So it's not the line. It's one of the great ways to make straight dotted lines if you use a ruler or something. And by the way, there are rulers up there on the table. You're welcome to use those anytime you would like. And notice it says y is less than. Well, the y-axis values go up and down, right? So since it's y is less than that, I want to shade beneath this line. It is all of that stuff. And some of you who are more artistic probably make that look better than mine, which looks like a 3rd grader did it in the back of the bus as it was going over the railroad tracks. All right, let's do another one. So y minus 6 is equal to 1/4 x minus 3. This is going to go through the point +3, +6, because the point slope form is y minus y1 and x minus x1. So this goes to the point +3, +6. And has a slope of 1/4. Since it's equal to, it is the line. So it looks something like this. If at any point I start going too fast, just let me know. Say, hang on, I need a second to process or whatever.
Wait, I'm confused.
Me too. What are you confused about? So I started at the point +3, +6.
Okay.
Okay? And then from there, I did the slope of 1/4. And you can see on this, the y-intercept would have been, I don't know, something horrible though, right? It looks like it's maybe 5 1/4. But even then, you would have to estimate where the 1/4 was. Ugh. All right. Now, for this one, this is in point slope form also, but they've moved this to the other side. The coordinates of a point on this one, it's going to be -4 because this is supposed to be x minus 4, but this is the y value, so it's -4, -2. Some people prefer to go ahead and add this over so that it looks like this one. It's up to you. Grace, you look like you're thinking hard.
Can you do what you were doing again? I'm confused.
Okay, so with point slope, it's either y minus y1 is equal to m times x minus x1, or it's y equals y1 plus m times x minus x1. So to get the x coordinate, you're always going to look inside those parentheses, and whatever it's x, here it's x plus 4, so it must have been x minus -4 to be x plus 4. Okay, so that's always going to be the opposite. If it's in this form, the y is also going to be the opposite. So where it's y minus 6, that's going to go through 6. On the y coordinate will be 6. On this one, notice it's just the y by itself, so you keep the sign. Okay? So then, for this one, I'm at -4, -2. And my slope is -2/3. Notice this one has underneath the greater than, it has that little bar. That means it is equal to. So this does include the line. So it's like so. And this is a greater than. Y greater than means that it's above this line. So it's everything above that line. All right, then x equals 3. Well, that's just a line that goes through the x-axis at +3, and it never goes through the y-axis. So it's got to be this. Which, when you think about it, totally makes sense. It doesn't matter what point I pick on this line, what is its x-coordinate? Which is what this says. This says the x-coordinate is always 3, and we don't give a rip about what the y-coordinate is. Okay? We don't even mention it. Okay. Now let's talk about solving systems graphically. You've done this before. You did this in pre-algebra. So if you've got a system of linear equations, one of the ways that you can solve it, and we did systems earlier this year, right? We did solving them by substitution. We did solving it by elimination. Lots of different things you can do, but you can also solve it by graphing. So let's take a look at these. Basically, you just graph them and see where is the intersection. So I'm going to put my graph up here above it, so I've got lots of space. All right. So y equals 2/3 x minus 4. The y-intercept is down here at -4. The slope is 2/3. On these, I'm especially careful to count the slope in both directions until it goes off my grid, because I don't trust myself if I'm doing this freehand, and I'll go ahead and draw this one freehand, to be accurate enough to get the point that I want for both lines. And then for our second one, the y-intercept is +2. The slope is -1/3. All right, so once it runs into the other one, I'm happy now because it had that point. So the answer to this one, or the solution, is 6, 0. All right, let's try this next one. So these are both in point slope form. So the first thing I need to know is what point does this go through? This is going to go through the point +1, +5. And if you think about that for just a second, if I substitute +1 into this equation, that'll be 1 minus 1 is 0, times 3/4 is 0, so y's got to be 5. And it's got a slope of 3/4. 1, 2, 3, 1, 2, 3, 4. So I'll also go down 3 into the left 4. And then for the next one, it's going to go through the point x is -1, y is +4. Which is really close to this one. And it has a slope of 2/3. And that one's close, but not quite. This is why I draw it all the way to the edge. 1, 2, 1, 2, 3. That's the one where they cross one another. But they're so close to each other, if you don't plot multiple points, you're likely to go, oh yeah, that's the right one, and it's not. So these cross at, what is it, 5, 8? All right, and then last one. And this is one where, especially this one, if you asked me, solve this by hand, do it as fast as you can, I absolutely would not graph it. But the instructions here said solve it by graphing. Why wouldn't I graph it? Because all I've got to do is substitute the 6 in over here and then crunch the numbers to find the y, and that doesn't take very long. But we'll go ahead because it said show this by graphing. So x equals 6 is just a line where all the x coordinates are 6. So I know my answer is going to be 6 something. This goes to the point where x is positive 2 and y is 3. 2, 3, right there. And it has a slope of negative 3/4. Well, that one was really easy. You only had to count the once, and there it went. So it turns out it's 6, 0. All right.